So there's a general sense to the term economy that I'd like us to explore over the next two terms that has to do with a kind of general set of relationships. So you can think about something like Freud talking about the sort of psychic economy of the mind. And here we could use economy perhaps as a term that might prove useful, as useful, or maybe even more useful than other sorts of E terms like ecology, like environment, like that, as a way of thinking about the implications of both generalized systemics, but also man's particular valuation system within it. Now that's a sort of big charge, and we'll see if we actually get to any of that material over the next 2 weeks, or 2 terms. That said, and with no onus to address these terms directly, I'm pleased to announce Heather Roberge, who is a practicing architect and educator in Los Angeles. She's Associate Vice Chair of the Department of Architecture at UCLA and is Director of the Undergraduate Program in Architectural Studies. She teaches graduate courses in design and technology. Formerly as a principal of New Forum, Ms. Roberge explored an architecture of effective atmospheres through a vitalist, materialist model of practice. Murmur, her new office, continues these investigations with a special focus on the spatial, structural, and atmospheric innovations made possible by emerging digital design and manufacturing techniques. Mrs. Roberge received her Bachelor of Science and Master's of Architecture degree here at The Ohio State University, where she received the AIA Certificate of Excellence and graduated summa cum laude. In 1995, Mrs. Roberge also studied at the Architectural Association, and I should also here add that we're particularly pleased to have Heather speak to us tonight about the implications of her practice, but also welcome her back to the school, not only as a visiting speaker, but also as a visiting professor, as she is currently teaching in the graduate options studio, and so we're very happy to have her back both tonight and for the term. With that, please help me welcome Heather.
With all the microphones, I feel like I should step into the set of Matrix, the Matrix. Let's see. I have several different slideshows, so I'm going to start with this one, and I'll give you an outline of, before I get started, of exactly what I'll be talking about tonight. I've decided to share both professional work and some of the design research that happens in the context of my teaching, because I find that the two are constantly in conversation with one another, and that increasingly things that I discover in practice shape problems, the problems that I set up in teaching. So I'll give you a brief outline of some of my research interests. As John briefly introduced, I'm interested in the ordering systems that are interior to architecture, space making, figure, surface, atmosphere, and material assembly as exterior systems like energy, gravity, wind, program, I would call that an exterior system, and technology flow through them. And these interacting systems produce emergent and complex design ecologies that reorganize the systems themselves as they interface with one another. In my practice, these design ecologies are born generally of material experiments with geometry that then produce a series of cascading implications in the resolution of other systems like tectonics, assembly, aperture, cladding, etc. And I find that by kind of foregrounding distributions of geometry, I'm able to kind of challenge some of the standard typological conditions that come with things like building organization when understood from a solid logic. So you'll see a lot of projects that use surface as their kind of primary place of description in order to upset the kind of spatial boundaries and orders that come with solids. And in addition, some of these interests in surface have to do with observations and study of contemporary surfaces in Europe and Japan, which have influenced some of my teaching. So I'll start by answering in his absence Jeff's insistence that I show you two houses that I've worked on in professional practice. The first was a scheme that was produced with my former partner Jason Payne for a house in Malibu. The second is the same exact program, same square footage, same site, redesigned after the county rejected the scheme that we had proposed and that I had submitted for permit. And that rejection, I think, has one official cause and an unofficial cause, and I'll explain a little bit of that to you. So one site, two houses. So it's with caution that I proceed to make two equally compelling arguments for different schemes on the same site, which seems incredibly challenging. So this particular site is about 1,000 feet above the Pacific Coast Highway, overlooking the Pacific Ocean. Physically, the hillside site is in its surroundings is incredibly rugged, but the site itself topographically is pretty manageable. There's a flat building pad once occupied by a house that burnt down about 15 years ago. And the client is able to replace this house or to develop this site because at one time a house existed on the site. But under a normal development scenario, they couldn't develop this site, which makes the project incredibly complex. It's developed under a zoning exemption, which is exercised at the discretion of a building official, which means that in hindsight, this house was incredibly problematic from the point of view of the building official, given the development conditions of this site, which this site can be developed as a hardship provision for people who experience a natural disaster. And in an unbelievable instance of naivete on my part, I didn't take that into consideration, the political ramifications of exercising that kind of exemption. So this is the first proposal. This is a two-story house. It's a doubly curved house that was really designed in an incredibly nuanced and torturous way, to be quite honest, because it's doubly curved and it has really tight constraints on the square footage. We really had to design the house as if it were a kind of organism developing in an incredibly constrained environment. So as some of our initial source material, we were looking at Darcy Thompson's index of external force on different species of animal. And we used a kind of initial model, which was a Klein model, topological model, because we had two different types of space to produce in this house. One was interior space, conditioned interior space. The second was unconditioned exterior space. And this geometric device allowed us to use the same surface description to describe both kinds of space. And so we went through a series of models looking for a kind of organizational diagram for the house and settled on what's basically a manipulated torus. And the torus is manipulated for access, for views to the ocean, and for programmatic reasons. This is the sort of last schematic diagram of the organization of the house. And you can kind of see in this diagram that the torus is snipped at one point along its continuous length and sort of spiraled on top of itself, so it becomes a discontinuous torus just through that operation of cutting. This is the site plan, and the access to the house is from the east, which is on your right. To the south, 200 degrees to the south, is a view of the ocean below, and 160 degrees to the north are rugged, rising mountains and ridge lines. So this is a view of the house that, from the entry side, from the east. And you can see that when the torus is cut and rotated on itself, it produces a kind of overhang where entry into a central courtyard and into the house happens. And one of the kind of longest refinements of the design was a search for an affordable structural solution for achieving double curvature. The house is about 1,800 square feet, so it's an incredibly tiny house, which means that there is no space for kind of poché in the wall. The wall needs to be as thin as it can in order to preserve the space of the house. And these are a series of structural models that we did in search of the answer. One is a kind of involuted grid shell. Another is a series of kind of intersecting ribs. This one here, which looks like a kind of shell, is a monocoque solution, and the other was a series of serial ribs. This was another that we tried, which was sort of a hybrid where the floor plate of the house became a kind of structural member collecting the load of the roof above it and helping to bring the load to the ground. So these are just a series of early models. I'll show you how they develop. The important thing to see here is that there's basically one spiraling floor plate, which is the bottom of the clipped torus. And on top of that is then the enclosure for the house. And so in the floor plan, you can basically see how you enter up a stair to a raised courtyard, and you enter the living room and move up to the left to go to the master suite, or there's a kitchen and dining room to the right. And then upstairs, when you arrive upstairs, there's just one large master bedroom suite with closets, bathrooms, laundry, the master bedroom, and a terrace for doing yoga. And at the top of the stair, if you turn and switch around, you can exit to, I think it's number 11 there, which is the roof terrace, which is sort of outfitted in the top surface of the building massing. And this is sort of showing the shell sliding over the top of the program and into the center courtyard. And for me, one of the most fascinating things to work on was the structural solution, because I think that I discovered every way in which our building codes make double curvature inefficient, and how double curvature is not defined in any of the systems that that are defined in our building codes. So that meant that a lot of the conventions of residential construction were impossible to use, not only because of the kind of formal pressure that the House put on those systems, but also because there would be no performance use value for those things, in the environment of the building official. So this is a diagram which just shows how how the structural system is produced. From number 1 on the upper left is a series of 35 5/8 inch plasma cut steel tubes. So they're incredibly thin in their thickness, and they vary from 6 inches deep to 9 inches deep, depending on where they happen relative to the form. And in number 2, and those all kind of move around radially around the central courtyard. In number 2 is a series of timber laterals that are connected to laterally stabilize the steel ribs. In number 3 are a series of braces that basically resist shear in the house, and that's necessary because we can't clad the house in plywood in order to resist shear from a building official point of view. And then number 4 is just a kind of ghost of the exterior skin and the start of a series of apertures that puncture the skin. So here are all of the ribs laid out, and you'll see that sometimes the rib is a 2-story rib, sometimes it's a 1-story rib, and toward the bottom of the screen you'll see that there are other places where the rib is kind of transformed in order to produce flat spaces for occupation. And this is the structural diagram of that house from the top view, just showing how the lines of structure converge in the middle. And then I'll show you a few more things, one of which is a structural model just made in chipboard that was used to test the kind of empirically the structural behavior of the system. And also, I'll spin the model around so you'll have a chance to see how the different, how the basic typical rib is altered depending on its location around the torus. So in number 1, which is the location of the top of the stair and the top of the stair, which makes an entry sequence underneath it. The rib sits on basically a spanning platform, which you can see here. And in number 2, the rib gets a series of plates welded to it to become columnar and hold the second floor plate, which you can see on the right side of this screen. So basically the rib sort of absorbs the diagram of a wide flange section where it needs to in order to hold up the second floor. And then in number 3, that's where the roof deck kind of gets situated on the top of the house, and you can see that here on the left side of the screen. So then this is just a series sort of showing you how the torus absorbs the second floor of living and moves around. This is the entry side, the stair going up, the living room with the roof deck above, and that's the top floor plan. This is a detail of the roof deck showing how the form kind of cradles and nests occupation on top of it. And then this is the underside of the living room looking up to the master bedroom suite, which isn't rendered in that model. So in addition to, so at this point, the logic for the frame was complete. But because all of the resistance of force occurred through the frame, we have more frame than one wants to have. And we were able to, on diagonal cascading lines, to remove approximately every other diagonal brace, so that we were able to punch the shell with a series of round apertures. So they're kind of light here, but there are a series of circles that sort of cascade over the form. And these are 2-foot diameter round windows that give you sort of unusual views of the landscape. But the house is so small that you're always in close proximity to its surfaces, so the window is kind of always it's always in relation to the body as it's moving up into the space of the house. This was a sort of atmospheric image to kind of an inspirational image for how the aperture might affect the lighting conditions inside the house. And these are a series of elevations that show the round windows sort of diagonally cascading over the form. And a series of, screenshots of what those do in the interior. And those same apertures slide onto the roof as skylights, so you can continue to track the diagonal sweep of both structural load and apertures over the top of the space. And then the last section of development, which wasn't fully developed when we submitted for permit, was how the cladding system would work. And so a lot of the renderings just show a kind of smooth monolithic skin, but we did a series of studies to analyze how we could clad the house in copper shingles. And really Knowlton Hall was one of the inspirations for this when we were here in, I think, 2004, which was to try to figure out how we could use bands of shingles of the same height and just use a series of darting operations, or what my students are learning about, which is called godets, to basically alter, almost like in a garment making way, the amount of surface area we were covering using strips of shingles. And this study also located those shingles, 3 different shingle widths according to the path of rainwater. So we had planned for the shingles to be copper and to locate more seams in locations where water ran in order to kind of accentuate and accelerate the changing colors of the facade as the copper went to dark bronze, and eventually portions of it would become green. So here are just a series of sections through the house, which show the courtyard space and show the interior space. And as much as possible, there are as few partitions as possible in the house, which is mostly accomplished except in the master suite for privacy and bathing and that sort of thing. Here, the lower section is a section through the roof deck. And then a series of wall sections. And this house is in an extreme fire hazard zone, so there are many layers of the house and many decisions that are made in order to increase the fire rating of both the deck and the shell of the house. So now I'm going to try to make a better argument for the house that I'm building. So this house we just are hiring a contractor now, and I call this house the VORTEX house, largely because of the plan arrangement of the house and also some of its kind of passive cooling strategies. So this is a view of the house. This is the sort of thing you're not supposed to say, but I had a very strong desire to make sure that from a couple of views, the house presented itself like a kind of conventional gable-ended house in order to communicate with the building official. So in order to do that and also do something that was spatially and architecturally interesting to me, the house is organized as, it's organized through basically a folded roof plane, which I'll describe to you a bit more formally. So the project's ambition lies in its dramatic spatial modulation and the saturation of its interior with the visual and geometric material of the surrounding site, rather than understand the views as a way to release the interior to the exterior. The surrounding geometric and topographic features are drawn into the interior to condition its atmosphere. And I'll talk more about that in a minute. You'll see this is, it's a 5-sided object in plan, and it has a courtyard space to kind of expand the living space of the house. And the 5-sided object gives you a minimum of 2 edges of exposure to the views. So every room basically has 2 walls to the exterior. And on the southern edge of the house is a covered patio, which basically protects other areas of the house from the sun and also gives you the most expansive contact with the kind of material of the site beyond. So the idea is that both artificial, which in this case the artificial geometries are drawn by the profile of the roof, and they're drawn by the profiles, the kind of edges of the apertures that are cut into the walls. Those artificial geometries and the natural geometries of the distant ridgelines are characterized as of the same fluid medium and the house of vortex into which that material is drawn. And that ambition informs each of the parts of the house's organization, the sculpted form of the massing, the roof, the patio locations, and the exterior wrapper. And this is a Lautner house, which I'm sure some of you have seen, which is in Acapulco, which is from 1971. And the house does an incredible job of using this large, curving, sweeping concrete roof to frame distant views. But the ambition of the architecture seems to me to be in part in service to revealing the wonder of the natural environment. And in this case, in the house, I'm interested in the kind of environment that's only possible in viewing the distant landscape in relation to the constructed geometries of the house. And so rather than frame the landscape, the idea is that the openings actually introduce other profiles, geometries, and surfaces into the interior environment. So these are views of the house. The top, this is a northern view. It faces rugged mountains. The roof kind of extends out to make an opening in the massing of the house, and the entry is made behind this kind of angled wall. And then this is a view approaching the entry. You can see the light kind of on the patio there. And in the other direction, which is south-southwest, you can see the ocean beyond. This is a fully cheated rendering. The ocean is 1,000 feet down, but you do see it at the horizon about where you're seeing it. You just can't see the waves break. Instead, you see the body of the water. And so this is the plan. The entry's north, which is up on the screen. There's a kitchen and living room and a two bedrooms, walk-in closet, master bath. The courtyard space is in the center. It helps in this 5-sided massing with this covered patio. There are many opportunities for using prevailing winds to sort of bring air in through the house and allow it to exit on the two opposite walls or through the courtyard in order to move warm air out of the house. And perhaps the most interesting thing for me about the house spatially is that the folded roof plane of the house is revealed to the interior space. So the space rises toward the center of the courtyard, and at the bottom of this screen you'll see a series of abstracted ceiling scapes which show how the space of the house is compressed at the edges and it expands toward the middle. This is a western view of the house. And this is a kind of diagram of the airflow that takes advantage of the configuration of the house and location of apertures. And then these are elevations of the house. You can see that the roof is always sloping to the perimeter, so you have views of that plane that are that disappear and reveal themselves as you move around the house. And then a west elevation and a kind of study model an early study model of the house. So in order to produce that roofscape and not have a series of ties that would create a uniform ceiling, the house is basically a hybrid of a steel tube frame and typical timber construction, and those two things are fused. So in the walls, the steel tubes interrupt the framing, the kind of, conventional framing of the wall. And on the roof, this folded plane makes a platform for a series of wood joists to rest. And that allows the house to be kind of made using pretty coarse tolerances in the steel. And we rely on the wood to set all of our kind of critical points in the roof plane. On the right-hand side of the screen, you'll see that there's a view toward Malibu Pier and the mountains to the southwest. And then on the lower image, you can see what's happening in the ceiling plane of the house. And then that's the same view to end that sequence. So part of the interest in that house came out of a general interest in defining and putting into play geometric sets of geometries. And I was going to show a series of projects, a couple of these, I think all of these are basically new form projects where one geometric decision basically produces novelty in another one. In this case, a programmed basin for the Queens Museum of Art produces an intelligent geometric system of a suspension cable net which holds that up. And with it, that structural invention brings a kind of atmospheric side effect which became more interesting to us than what we started the project with. This is a model of that which I've shown before. In a completely different project, this is a design build, the products of a design build seminar at UCLA, where we had a series of students who did an acoustic treatment to our auditorium, and using a series of thin 18-inch wide strips of felt, we came up with an attachment system and a kind of an attachment system and a series of terminations which made that very thin felt surface a kind of rhythmic and volumetric treatment to the walls. And in my academic research, I've been working on trying to describe this condition which I call the synthetic reel, which is when two or more systems kind of are married to produce conditions that neither have on their own. So I'll show you a series of examples where this happens primarily by using plastic and the geometry of digital design and fabrication. But I have a video only because I think it's funny. Hold on a second. So in order to explain the kind of benefits of the synthetic reel, I have a contrast between two videos. I hope the sound's not on, because one is Super Mario Brothers, which came out when I was young. And Super Mario Brothers basically simulates an environment where there is no gravity. So if Mario falls, he's in one piece and he continues to move through the environment of the game. And there's no interaction between the body and the environment that it exists in. Then this is a Japanese-produced game for the PSP, and I only know this because I have a 7-year-old. But this particular game I find fascinating because there are a whole range of mediums in which these kind of blobby characters exist. So there's water, there's gravity. You can see that the body actually slumps and hangs in the space of the game. And so this one I show to contrast the lack of interface between the environment and bodies in the Mario Brothers game. From current slide. And so you see these sorts of kind of synthetic mixtures of naturally occurring things and artificially occurring things in everything from art practice to contemporary facades. So on the left you see, unfortunately, a still frame of Tim Hawkinson's A Motor, which is, Tim Hawkinson is an LA-based artist who uses a kind of video interface to send data to a series of actuators which are attached to acrylic planes that sort of relocate through rotation parts of his features. And in doing that, it produces a series of a kind of unfolding a series of facial expressions that aren't possible without the kind of digital mediated data. And as a result, it provokes an incredible number of kind of feelings and sensations in the audience, from horror to laughter, as you kind of watch the face take on expressions that are unfamiliar. In the Herzog and Demeron piece, a really simple operation of taking a series of glass planes and tipping them in a variety of ways on 4 fixed points basically synthetically represents Basel to itself. So even though the massing of the building is very polite and follows the kind of zoning criteria of the city, which generates kind of homogeneous sightlines in the city, on the lower right you can see how that kind of play with the crystalline and reflective conditions of glass produces a much more kind of disrupted view of Basel. And I think a really sort of contemporary moment of this is in Avatar, where Cameron takes both bodies and environments associated with the sea and in foliage and animals associated with the forest, and hybridizes those so that viewing the movie is like being immersed in a biome that we don't have, but that he's able to potently construct in the space of film. And I guess as an aspiration, that's my hope for what the introduction of technology to architectural material can do for architectural environments. And I've been kind of working on this under different guises for quite some time, in new form with animated simulations of line work translated into actual kind of environments of line work, which was on display here. It looked better here than anywhere else. And in the competition that Jason and I did as part of New Form for PS1, in 2006, we were one of 5 finalists to produce a scheme for PS1, which hopefully everyone knows the kind of program. But our scheme was called Purple Haze, and it was probably the design project with, funny enough, the least amount of constraints of those that I've shown. But despite the fact that you had to deploy this for very little money, the ambition of the project was quite expansive. So the project was named for Jimi Hendrix, Purple Haze, and our project creates altered sensory states similar to those described in the song. Primarily corporeal rather than conceptual, the proposal produces these altered states with vast fields of potent color combined with pronounced optical, tactile, and auditory effects. So this is a kind of rendering of the scheme. The scheme had a series of layers from a canopy to a kind of artificial climate to a loungescape. These are displayed here from top to bottom. And from a structural point of view, we did our best to reduce material weight. And so all of the material that's introduced in the project is as much as possible put into tension so that we didn't have to have a lot of frames or, you know, kind of structural frames, or to mold the parts into kind of rigid configurations. So we strung a series of steel cables across the existing courtyard space, from which we hung strips of magenta canopy, and those just take a catenary form because they're suspended. And then from that set of suspension cables, we put in a water distribution system which produced rain, mist, and fog to kind of thicken the literal atmosphere of the space and to cool the partygoers in the summer. And then on the lowest level is a loungescape. Each of these kind of toroidal-shaped loungers has a wading pool in the middle and is a series of plastic tubes that are wrapped around those. And the loungers basically index the presence of one another or the walls in order to take what is a flat platform and kind of compress it to produce more ergonomic single-person seating. And our idea was, this was following a proposal that had very little seating the previous year by Hernan Diaz-Alonso. And so we were trying to get as many people kind of comfortably outfitted in the space as we could. So these are 18-foot diameter loungers. They're really large, and they go from, you know, kind of controlled seating to flexible seating, which is shown in this diagram. And then these are just cross sections of those loungers to show how they sort of swell and fall in the space. And this is the sort of purple haze of the title, which is basically the kind of interaction of light moving through the translucent purple canopy and the mist, rain, and fog that's produced in the space below. And then in order to get a kind of rhythmic correlation between the systems, we made a series of perforated cuts in the canopy to let more sunlight through spaces where people dance and less sunlight where people rest and sit on loungers. And we allowed those cutouts of fabric to remain attached as flaps that would kind of move and sway in the breeze. This is a top view of that site plan. This is, in the small gallery, is the kind of wettest area of the scheme, and on the other side, the large side, is a much drier side of the scheme. And then this is just a site plan showing how this fits in the courtyard. And this is a worm's eye perspective of the underside of the canopy pulled up to show the loungers inside. And then these are a series of sections which show the kind of suspension of the fabric canopy, the fabric flaps that move and are stirred by breezes, and the loungers below. And so for us, we were really committed to trying to make all of our choices fit to all of our material choices to stimulate more than one sense. So we were trying to both literally and optically stimulate the sense of touch, to make decisions that would introduce sound into the environment, and to sort of make something that was visually rich and dynamic. So that's the kind of image of the way light falls on the ground and surfaces below the canopy. So the last thing that I wanted to show is is a whole line of research from a series of technology seminars. And this is probably the only place in the talk where I can, in part, really legitimately speak to the theme of economy, though I do my best to figure that out. In this particular seminar, we have an incredible program of technology seminars, which are fabrication seminars in our department. And in our department, digital prototyping has become something that students use to produce scale models of their design work, but something that is less and less likely to actually inform how they think about full-scale production and design. And so I designed a series of seminars to actually challenge the use of that equipment in that way, with the hopes of having students understand that the equipment, the constraints of the equipment are not constraints at model scale, that they are for the purposes of design, but that doesn't help you make design decisions that are meant to be blown up to one-to-one scale. So we use the equipment to prototype full-scale things, and in doing so kind of started producing these mixtures of material. The material was the digital description, it was the plastic and the color that students were introducing to a series of designs for rain screen panel arrays. And so the main kind of research outcome of it was that students were able to take these systems, mix them together, and produce materialities that weren't native to plastic or ultimately aluminum, the things these were meant to be made from, but were kind of mixtures that produced surfaces that that had qualities we find in fabric, cast ceramic, latex, and a variety of other materials. And this kind of came out of some interest in how practitioners in Los Angeles were using these same tools in their practices. I'm going to skip this because I'm being long-winded. Okay, so these are a series of projects which I'll introduce, and I'll give you a little bit of background to the organization of the course. So the thesis is that material reality has become plastic. The technology of design and the technology of manufacture alters materiality, breeding what I call synthetic materiality. This is a constructed set of surface effects resulting from actual material properties and the geometry-induced properties of digital operations. In the most captivating mixtures, the real and virtual become so intertwined that one produces a new synthetic materiality, and the optical and tactile sensations produced by these surfaces bring a new lushness to design research. So these are some kind of sampling of the projects produced. And the course is designed and possible really because of some technological shifts. One happened a long time ago, but is really producing fascinating architectural surfaces, which is the release of the exterior wall from first the burden of carrying building load, and second from the burden of creating a weather-tight enclosure. The second shift in technology is the tools that we use to describe our designs, to basically produce them. And so both in the space of drawing and in this, in the space of drawing, which is in the space of manufacture, we're able to control much more geometry than we have been able to in the past. The third shift is in the relationship of our design instruments to tools of manufacture. So we can now directly instruct machines to produce our drawings or to produce drawings which become three-dimensional things. So for the course, I found a thermoforming company in California called Superform, which produces parts in that number in the hundreds versus, hundreds of thousands, the way certain processes in automotive design typically happen. So Superform uses a superplastic alloy of aluminum, heat and pressure to, using a one-sided mold, construct pretty complex forms. And in this case, they produced some of the parts that were more economically produced on this Ford GT through their process than stamping. And they also produce the kind of doubly curved, more difficult transitional elements in aircraft. So they do the lip skin, which goes on the leading edge of an engine, or the kind of elbow between the body of the aircraft and the wing. And they, you can see here on the left is one of their steel vacuum forms, which it basically gets clamped shut to produce a seal so that you can apply air pressure to a heated up sheet of aluminum and press it with air pressure over a tool. So I asked my students to adopt this manufacturer's parameters as their primary constraints for developing tessellated panel systems for making cladding. And in order to do this, we CNC milled foam forms, put ABS over them to construct a form for vacuum forming. And we prototyped this with department equipment using a vacuum former. And then we used our CNC again to kind of do a post-production where we could use cutting to trim our panels or to change our panels through a series of cuts. So in order to really tightly describe the parameters of the course, I introduced a series of vocabulary, which is really familiar to people who know how tessellation works, but we use plane tiling, which means you use I only allowed them to use one or two tiles that when you aggregate them through translation or rotation, give you a closed, complete surface. And the tile boundary was just the shape of the perimeter of the tile. And then we had field line work, which was a geometric system that would intentionally kind of breach the boundaries of the tile and try to hide the repeated geometric logic of the system. Print the field line work and the tile boundary into the surface of the panel. So the resulting schemes, and just to clarify what thermoformed superplastic aluminum is that the aluminum basically at a certain temperature behaves like taffy. So the aluminum has an incredible stretching coefficient. It will expand and it won't yield. And then when it's cooled down, because it's heat formed, there are no residual stresses in the panel, and the panel becomes incredibly rigid and strong. So you can produce panels that are under 1 millimeter thick, but that can resist wind load that we associate with building envelopes. So these are a series of projects which I'll describe the synthetic material qualities of in brief detail. These are the kind of fabric strategies. There's the kind of weighted fabric. There's more organic membranes. There were a series of more metallic standard solutions. There were cast solutions, seemingly cast solutions, and this is a prototype done in aluminum that Superform did for me. So satin sheet is a 2-tile system. It yields 72 standard panel combinations that were categorized and described by the designers based on how the field line work moved. Dichroic paint finish heightens the sensation of continual movement that the field line work instigates optically. The surface recedes and approaches rhythmically as one's movement alters the color of the surface. The field line work progresses linearly, curls, tangles, and moves again depending on panel orientation and adjacency. Bust-align was, and I didn't title any of these, Bust-align is a single tile system, so they use one hexagonal tile, but they really cleverly developed a series of tool inserts, which you can see in the lower left image. So, and this is something that Superform can do. So they basically put tool inserts of different heights to kind of raise and lower the description of the hexagon boundary. So it looks like a cloth is being sort of variably blown against a kind of hexagonal honeycomb in the background. You can tell me if you believe any of this later, John. Shiatsu takes advantage of the duration of thermoforming to modulate air pressure through a series of independent chambers. So this group of students really rejected the single or the 1 or 2 tile constraint and instead kind of engineered a series of air chambers where, almost like music, they could turn on and dial up or down air pressure into a series of chambers to produce these features across the surface. And the resultant material effect, so you can see that just by altering the air distribution device, they have, an unlimited number of degrees of freedom through which to describe the surface. So the resulting effect resembles latex informally stretched from behind, and the features sort of rhythmically and unexpectedly emerge. Point Blank was a more recent addition in the 3-part course. This one is interesting in that they too had a real problem with the kind of 2-tile constraint, and so they merged several hexagonal tiles in order to produce a cluster of 4, and by using lower cost, simpler manufacturing techniques like stamping, they made a series of blanks as well. So they were able to have a variety of forms, 2 of which could be produced with really simple methods, and 1 kind of meta cluster was produced through superforming methods. And in this particular iteration of the course, I made students design the kind of terminations at the top and bottom of the wall, and folds in the surface, so they'd have to figure out corners. And so this one is also a bit like a kind of stretched membrane. And these are large, like 10 by 8 prototypes of these systems. Tongue-in-cheek produces a similar material quality. Here the panel appears to slump under the weight of a substance within. The designers developed 2 tiles, one slightly convex and one slightly concave, that together generate remarkable surface undulation with nearly indiscernible panel section variation. So the parts, they put the parts together in 3 ways, through canoodling, zippering, and something else, but basically, diverging. And by doing that, they were able to have the form sort of move over the seam so that the form itself would hide the seam. And they did that by being clever about the way in which they produced the form over the mold to eliminate an undercut. And this is the curvature they get across 10 feet with 2 panel types. In intestines and roses, students produce a remarkably lush, fleshy surface quality using geometry that imbues the surface with tension. The surfaces seem fluid-filled and organic. It's a 2-tile system that disguises its boundaries by merging 3-dimensional surface features with the 2-dimensional line of the tile boundary. So they basically redraw the hexagonal boundary so that its character parallels the character of the field line work. And so you're able to kind of lose the tiles in this field of excessive line work. And so they also used a finishing technique to enhance the character of the surface. The deep areas of the panel received darker tones of red, while the forwardmost surfaces remain bright. This finish accentuates the panel morphology and convincingly fills the surface with substance. This one is called Nurples. This one uses a very similar, there were men in my tech seminar class. This one uses a very similar strategy to intestines and roses, and they also developed a series of, you can see in the lower right, a series of masking, laser cut masking devices so that they were able to use the same set of tiles, but through the application of color, achieve more painterly effects. So it's a bit like kind of looped carpet, and you're able to basically apply color at will using this series of masks. And this one also has a sort of slight undulation that moves the surface out from the kind of planar substrate. And that's their really excessively large prototype. But you can still see the sort of darker regions where the seams are, but it's hard to really call out where exactly the part repeats. I'm going to skip this one. And I have 2 more. This one I just call doubly curved panel. It's uses just one tile. I think it uses 2 triangular tile types and a series of variable connections in order to produce double curvature. So you can see in this prototype on the left, it goes from a convex surface, and on the right, it goes to a concave surface, all through the design of a connection system. And then this one was produced sort of in the middle of, like halfway through the experiments I just showed for Matters of Sensation, which was a show at Artist Space in New York. And I got the support of Superform to produce one panel and at a particular size because they had a kind of housing that was already made that they could snap a mold into, which meant I could make a mold for $2,000 instead of $25,000. And the mold is produced by milling. We were under a tight deadline, so I just milled a piece of aluminum. And in this case, I knew the limits of a one-tiled system and the amount of time I had, so I wanted to basically test the kind of smallest scale details that Superform was able to manage. So in the center of these three clusters of hexes are a series of kind of jewelry scaled features in the middle of these masses. That's the mold that was locked into this existing surround. And then the parts are each made in 20 minutes in a giant heated press. And then they're cleaned, trimmed, and we produced a kind of plywood substrate that clipped these on so that we could just simply hang it in the gallery. And these are the students who did all the research you saw before. So that was it.
Any questions for Heather? I mean, one thing that I was curious about, I really appreciated the work, both the student work and your own. I think it made for an inspirational set of projects to see, especially at this early point in the quarter. I mean, the one moment that I think clarified for me the aspirations for the work is when you evoked Avatar as a kind of model for thinking through technology, for offering up a different sensibility and offering a different possibility. And then I was sort of thinking through that in terms of not that you have to follow the model exactly, but like that's a movie super expensive to make. It's now doing very well. It offers a kind of vision for the world. And not that it has to come back to economy, but I'm curious about like in the format of architecture, which in a way deals with singularities and multiplicities, and how you sort of see the work you're interested in, the scales of construction you're interested that can deal with this sort of effect-laden work in terms of addressing larger constituencies and how you sort of mobilize this aesthetic. I mean, the sort of cautionary tale of the house that you showed at the beginning, I think one could draw lots of conclusions from that. I'm not sure the conclusion is that one's necessarily more correct for the other, even though there's things you have to acquiesce to. So I guess other than like zoning regulations that come into the fore, what are the sort of challenges you see of this kind of work in terms of addressing larger constituencies or creating those constituencies?
Well, I think it's actually exactly Avatar that I am using to argue that we don't need to address larger constituencies. Like, it's not that they're not there, it's that we're not talking to them. So to me, that Avatar has generated the amount of wonder and kind of enchantment from articles by biologists in the New York Times to film critics to visual effects people and just laymen is because people want, I think, to be enchanted by the environments that they exist in. So I think we, as a discipline, aren't exercising authorship assertively enough over exactly the kind of fantastical, magical, excessive stuff that people want to experience. I think when I think that we probably don't have a shared vocabulary for discussing that with clients all of the time. So they talk to us about what they need, but we all know that they want things they can't articulate that they want, and it's our sort of sensibility and the excess we put in, which, like in the recent log 17, is what people are talking about as the superficial. It's the unnecessary stuff that is what people desire, I think. And I think that that should be the case even as our as demands on the performance of materials and the kind of economic viability and environmental viability of things. Those are pressures that continue to get kind of ratcheted down, but I think our discipline dies if we don't always keep in mind what we're doing with the excessive.
I think that's really great, really exciting. Especially interesting to me is the later stuff, where it seems like you are pushing the envelope of what architecture can do, not simply based on the image of architecture, but based on the material reality, understood based on new technologies. So I think that's great. I guess therein lies my critique of the first version of the Malibu house. Because in many ways it seemed like, oh, I don't know, a McKinley-White project, built out of steel, but decked out with a kind of highly artificial surface that pretended to be a different thing.
Mm-hmm.
And in that sense, very retrograde, in spite of its kind of super fantastic Jetsonian imagery. Whereas this stuff seems to be kind of prodding the material to yield the form and not allowing something that is a kind of preconceived idea of cool form, fine body, and letting that drive what the thing becomes. So a critique and a compliment.
Yeah, thanks. I mean, I think that in many ways, there are so many things taken off of the table in the student research that you don't have to question relationship to ground plane, massing, program distribution, relationship to exterior, very little even challenge of how you produce aperture in the facade, though we did try. But as soon as you start laying in some other systems, things get less beautiful. I mean,
I thought it was beautiful as a frame.
Yeah.
And my criticism is why you were so interested in covering up any trace of a frame and positioning it as though it had some different material.
I see. Yeah. That's a good critique. I mean, I think that's why I show the model and not renderings, because I never really knew what the opaque parts of the project should be. I had a much better understanding of the frame and the way the space was constructed by that frame than by the cladding. Did you have a question? Yeah? Yeah, he looked like he was going to raise his hand.
No, it's sort of a follow-up, because I think that the terms haven't shifted so much. I think maybe it's become clearer in that your complaint is that the frame doesn't want to look like it's a frame. But I think here what's exciting is they're probing what this super metal can do. But the ambition is to see how you make super metal look like other things or produce other material effects. It's going to look like Play-Doh, it's going to look like intestines. And so I think maybe it's a different context as a house versus doing a seminar, but it almost seems like you're zeroing in on the real project, which is kind of, if Jeff were here, who knows what he would say, but I feel like the words new authenticity would get thrown around, that this is about, in a sort of technological world, whether it's the technological world within Avatar or the one that we just live in, how to make things that feel real to us, even though we know they're fake. We don't actually care that they're fake. If I went to Avatar, I wouldn't care that it's computer made. What's amazing is the sensations I've experienced. And I feel like that's what's going on here. It's really cool.
I think that is, even though the kind of qualities of aluminum are kind of downplayed. I think in each of the projects, they're sort of foregrounding some other materiality. So they aren't doing it blindly. Very early in the design process, they know that they're going to try to achieve satin fabric. And it's because they kind of judge the resemblances of things that they're producing. And I think that part of my interest in these constructed materialities is I think that they are more easily embraced and engaged and acknowledged by audiences than in sort of stories that, or narratives that aren't something that a broad audience can access. So for me, the materiality is a way of getting attention, not for myself, but for the piece.
I also enjoyed very much the presentation, and specifically the presentation of the two house schemes. Because for me, what I enjoyed about your work is the small scale, the surface ornamentation, and then if you put that in the context of we're used to seeing large scale projects with large programs, that formal spatial diagrams become collections of smaller spaces.
Mm-hmm.
But the house in particular exists in between those two scales,
Mm-hmm.
and the struggle of how the geometry informs the space and the effects.
Mm-hmm.
It seemed that that was really obvious in the presentation of the two schemes, that was an interesting thing that you had. And I wonder, another question, how hard was it, a decision, when you went from scheme 1 to scheme 2, to kind of step back and start over, rather than try to rationalize the complexity out of the first scheme, while keeping a similar kind of arrangement of spaces?
The first scheme wore me out. The first scheme wore me out from every possible point of view, and the first scheme was designed in partnership. So the second, I mean, there was the difficulty of designing the second scheme had a lot more to do with starting to design as a kind of solo designer again than it did, changing geometric systems. But I was really determined that they weren't going to say no to the next scheme. And so, and it still took 2 years to get a permit, and really going to the top of building and safety because they think this scheme is weird. But I was really determined, so I made certain decisions about how to do things in a way that I could get done. I had an enormous time pressure on that project. I had to submit it in 5 months, so I had to develop it really quickly. And the doubly curved house was, took a lot more back and forth and finite element analysis and, a big learning curve to kind of get the structural engineer on board and even find an engineer who wanted to do it, and because it's not a huge budget building.